Good morning and welcome to Extending the Platform. I'm Ben Mailing, and joining us by phone from Texas is Andy Pardue. We're both with Medsphere Systems. Over the next little over an hour, we're going to be introducing a couple of technologies that Medsphere has made available in open source, and also going through a couple demos of those technologies. The first one we'd like to talk about is OVID, or OVID. It's a foundational technology that gives developers a tool to access the data and logic that's available within OpenVista and other Vista derivatives. Provides a number of tools and ways to access the data and logic in different ways. We'll be talking through those technical capabilities. But first of all, some of the vital stats on the project. Released in early 2009, available under a GPL license. Couple of mixtures of technologies, one on the Vista side and one on the Java side, and it's been downloaded a little over 2,000 times. You can see the project homepage and a link to a recent white paper that was produced with a gracious forward by K.S. Bhaskar of Fidelity Systems.
Use the OpenVista data stores to present data or even to change the data for other applications. And we kept it very simple at the beginning on purpose. And there are other things that do things that are kind of similar to this, and we look at those, but what we needed at the time, it just wasn't anything quite right out there. But at the beginning, what we did is we tried to keep it very simple. OVID at its core is just, it's based on Java, is the language that we chose to test what works for it. And we keep it very simple. Code jobs. We don't put any other technologies into our basic OVID stack. But by virtue of that, as you can see from this list, we can also extend that to other applications. A popular one has been self-based web services. Another popular one has been REST-based web services. And we've recently even incorporated into enterprise Java things running an application server. And we'll touch on all of those things here as we go through the presentation. Another capability that we haven't really exposed it a lot in our work, but it's there and we prototyped it, is the ability for Musco to pull out to Java via a network connection. And there's other use cases that I think we can do this. But the way we would do it, what we would envision is, say you have a Java API that sits out there and can't access data that's not easily accessible from us. Maybe a third-party drug database. We're looking up drug-drug interactions or something like that in MCD, or you want to look up something in RxNorm, and you don't want to port RxNorm into your Vista data store. We have a way that you could actually call from Helm out to Java. It's not very mature, but that's also supported. And on the last bullet point there, we create what we call Java domain objects, or we try to use that pattern where you abstract a little bit into conceptual layers what it is you're talking about, and let that layer deal with the details. So as much as possible, the users of the OVID layer, they don't have to be too concerned about all the internals of what's happening behind the scenes. And that works pretty well, for the most part. It's still very helpful to have a good knowledge of what's going on in the back end. Just as if you're a Java developer using a relational database, it's hard to do that if you don't know what's going on in the relational database. The same is true for FileMaster. Next slide.
Okay, go ahead.
All right. So this diagram kind of represents a layered look at how this is implemented. The things that are in blue represent code that's written in the Java layer. You can see there at the top that we have two attachments represented in the Java app, which is the staging console. You can even throw in like a JSP type of interface there. Anything that can call native Java. Of course, there's a way for it to trying to develop a repository of web services that we find useful as we develop things here at Medsphere. And so both of those things kind of go hand in hand. And the web services repo with it, they would both use, like, it's both of those. I'm pointing to my screen. I know you can't see that. I'm sorry. If both the web services repo and the Java apps, have the concept of a patient, they would use the same domain object for patient, or they could, the same repository object to get the information about the patient. Going down a little bit further underneath the domain object repository, whenever a request needs to go to OpenVista, we construct a simple little message that we send via an OVID connection. And we support RPC broker, we support the RTMS CIA broker, we also support VCM. We even have a custom one that if you don't want to use any of those, the transport isn't all that important. And we haven't done it, but in theory, you could even drop these requests in a JMS queue if you wanted to set your system up that way. Once it gets past your transport, we have some software on the OpenVista side that we install as a kit build and knows how to take that message, see what needs to be done, execute an RPC or execute a FileMan silent mode call, assemble the results, and return it back to the domain object repository, call it, and of course returns it back to the application.
Hey, Andy.
Yes.
Sam has a question.
My question is the message that you're sending from OVID to OpenVista, is it a new message structure that's different from the broker, or is it the same broker message structure?
It's really a message structure on top of that it doesn't matter which broker that you use. We actually have documented it. I think it's on Medsphere.org. It's not a secret what the message structure is. It's really a simple text-based message. So it doesn't matter what your transport is. Now I will say that when we use the RPC broker, we use the new style because we just can't get the old style RPC broker to work correctly for what we need. Does that answer your question?
Yeah, I think it does. Thank you.
Andy, I'll try to find the spec on .org and give that to Sam later.
Okay. That's it for me on that slide.
Okay. Okay, so as you saw yesterday, if you attended, we're starting to see OVID used as the basis for OpenVista and RPMS as a platform. We've seen a number of applications developed, a number of technologies built on top of it. This is listing just a few. We're actually going to go a little later into a few demonstrations here of some of the things that we have been doing, so you can see that stuff live. This list is probably the most up to date. The interesting thing, I think, is kind of a proof point for us was to see some of these things pop up without us having actually gotten involved. So a number of times now we've had a community developer just email myself or someone else that works on the ecosystem side and say, I've got this particular contribution or this particular tool I've built, and we didn't even know they were building that tool. And so from a proof point to Andy's point around simplicity, that kind of helps us understand that at least we're going in the right direction with the technology. People can pick it up and use it on their own without necessarily needing a lot of hand-holding from us. So the iPhone app is an example of that with the RESTful interface. The registration application was one that was a surprise as well, web application that somebody showed up and had built. So that's the type of contributions we've been seeing. I did want to show again briefly this is the sample web front end that we built just as an example of another way to use OVID when we released it. This code is in the open source repository as well. And I hit this slide yesterday and then stopped. There's a few more after this that are important, but I did want to reiterate what we're seeing is the integration is part of the strengths of Vista and RPMS. like systems, but it's also a double-edged sword. You end up with your data, your logic, and your presentation tiers very tightly linked, and it causes trouble in an environment where we are today, where we have new devices coming out on a daily basis. We got an iPad a few weeks back. We have this new iPhone out. People want access to their data in lots of different ways now, and we've seen the VA, to some extent, even to IHS, struggle with moving this forward as a platform. And so we see this technology and others like it as one of those enablers. And so I wanted to take you through a few examples of things that we're doing with OVID to give you a sense of the different ways it can be used. So this is, Andy, we're on slide 8, just so you're aware. This is an example of an integration tool that we built as a way for customers that have interfaces that may not, that may deliver images in various formats. They may come with XML metadata, they may not, they may come as HL7, but they want to get those images into the system. So we took the Mirth tool, we built a plugin to it that consumes the OVID technology and allows us to use Mirth to pull in HL7 or XML, or and as well as the files themselves, the image files, and then do all of the necessary back-end work on Vista to push those images into the Vista repository and have them show up as attachments to notes or other things within the system. And this has worked out very well in some of our customers who have an ancillary system that has, or perhaps is end-of-life, or they cannot get to work with the vendor, or cannot afford to work with the vendor to get a true interface built. This allows us to kind of bulk load things in over time. And this is just one of those examples. You saw the patient dashboard. As an extension to OpenVista, layering on top of OVID, we talked about that domain layer. So you've got lots of objects that you can work against. Built a patient dashboard application. And that application, as I mentioned yesterday, is really just the care management tool that the VA uses. So a lot of the same APIs are just exposed as a web page. And then this was the surprise to us. What ended up happening was the iPhone app developer came in and layered in the RESTful web service on top of it and built their web app in the same exact way. So basically using the same APIs we already built for the, or had wrapped for the web application, he did the same thing for the iPhone app. And that's kind of the point here, is these technologies tend to build upon themselves, and each next technology just gets a little bit higher in the stack. So another way that we can leverage this is we built a clinical flow sheets application, originally on the CIS platform and now on the CareView platform, that leveraged the OVID-based web services for the domains. So you can envision there, if you take away the orange cylinder, you can envision just data flowing between clinical flow sheets and OpenVista. When we were originally implementing it, we thought, well, one thing that we might want to do is anytime there's new data structures we want to store, we don't want to change the data definitions within the OpenVista system, we can at the same time put those data elements into a MySQL database. And in our prototype, we actually had that running. There's some questions around the operations of that, how you would synchronize those databases, how you would make them, how you would recover from disaster, those sorts of things. In reality, the flowsheets application that's now being, I believe it's going into QA on IHS's side, doesn't use any of the MySQL stuff, but this is the type of thing that we can do when you start leveraging that abstraction layer. And so to take it a step further, to Andy's point, because you can call back and forth between the two, you may have your first data bank drug information framework, and you might want to do queries against that for information about drug interaction and whatnot. Bhaskar.
So you talked about in the previous slide the disaster recovery and synchronization and so on.
Mm-hmm.
But if you were to use your plug-in to MySQL to have the MySQL database code defined on plug, then at that point you essentially only have all of your state in that one database.
Yes.
And now the recovery becomes very simple.
Yes, there are certainly lots of ways to architect it from an operations standpoint. the point that I'm trying to make here is the abstraction that we're gaining allows us a lot of access to a lot of different things. And so in the case of the drug information framework, basically this is a tool that First Databank sells. They have a lot of content in it around drug information, interaction data, all of contraindications, all of those things, and they provide their own API that you can access it. Well, to build an M interface between those becomes difficult, but because they provide that Java API, we can do that through OVID Web Services and get that data back into MUMPS more easily than trying to integrate it directly into the MUMPS world. So, and then to Bhaskar's point, even a little further, I would say, forget about MySQL. That just is one example. If you're not interested in a relational database, but you want to go with something that's more object relational or something that's more hierarchical, you've got Amazon Web Services, you've got Google's Big Table. It doesn't really matter. The point is you can use this layer to abstract and get at data and put data in various places. And it becomes more of, if you changed OVID-based web services here to Enterprise Service Bus, that's essentially what you're looking at. I'm not suggesting that OVID would be the only piece of that. You certainly would need more in terms of orchestration of a service-oriented architecture, but that's one of the technologies that could be used, and it gets you access to a lot more things, allows you to migrate in different directions depending on the needs of your organization. So before I move on from this, any questions? Okay.
Yeah, I would point out also that we've implemented something on this migration slide for clients that's very similar to what being shown, from older down, where we had clients that wanted to access OpenVista and FDB, and there was some data that needed to be stored that they didn't want to put it in OpenVista. It was really not very important data anyway, and so because MySQL was available, it was stored there. But from the client perspective or the user perspective of using the services, they have no clue what's going on behind the scene, and they don't care as long as it works.
Yeah, that's exactly right. And that is another way that we that is on a pricing engine interface, which uses OVID in the same way. Okay, so we're on slide 14, Andy, if you want to take this one, domain layer.
Certainly. This is kind of our business case for what we wanted to achieve as we developed this. And we didn't start with this. This is kind of what emerged as we've gone along. But a few of the things that are important to us is we wanted to add something there for people who were really interested in object-oriented and composite framework to develop against OpenVista. Also, we were hoping to make a sort of the ramp-up speed that it would take for a new developer who doesn't have a month or OpenVista or even healthcare background and coming into the Medsphere or coming into the Medsphere.org project family, to be able to get something going, to be able to somehow communicate, with what I call this rich data store from Vista. And to a great extent, I believe that OVID does this. I always say, though, that one of the first things that we do when we have someone new coming in, we come to learn something we can't follow and learn about most RPCs, because once you understand that, it's kind of like understanding your database before you can program against your data. Once you get to that point, there's a lot more kind of goes on, and they understand, how OVID facilitates some of that. What we found is, we wanted it to be extensible to other architectures, and I've got a list there of a few that we've done, but we wanted to make it where we didn't have to have a finite set. If someone wanted to use OVID in a Spring framework, we will be just fine with that. If you wanted to throw it into Service Next, you could do that. So the third point, with this repository approach, that's what we're trying to focus a lot on now. We're trying to build up a repository that as we do things that we think are useful, we try to put them in one place so that within Medsphere and outside of Medsphere, a common project can share work that's already been done. It doesn't do a whole lot of good to develop this great application that can access, patient order information from open system. It just close your project and it's not easy for someone else to get access to it. So that's another thing that we're trying to do with OVID is as we develop these, we're going to put them in there and often if possible release them out. Our intent is to release all of them out, but sometimes just for the nature of doing other work, we're probably on a more unstoppable thing. OVID releases. In fact, we have one that we hopefully be coming up with the next month. Slide 15.
Okay, go ahead.
OVID is kind of broken up the way we see it here at Medsphere into two levels. There's this really basic OVID API, which is where you find your RTC connection interfaces. We have some other things in there that we find useful that aren't specific to any particular list of data like connection for the RTC connection. We have a caching mechanism that we end up using a lot that is time-based caching. So you can create a cache of data that you pull out of open system, and as you put it into the cache, you can define the cache and say, okay, things stay in here for 5 minutes and then they fall off. So that you don't keep building up huge caches, you want to get rid of things and time-based use this and that. There's some lower level API access, which is what our domain layer is built on top of, lower level file management. In the same way that you can create an SQL query or a relational database in Java, and you can actually pull the results out by the name of the column and things like that. We have that level, that's our base level of OVID access. You can actually just create one programs that you go and pull this information out. And we also have an annotation that we wrote that you can create little documents that you can just define your properties and annotate them and define your getters and setters. And if you set it all up correctly, they're pretty easy to use to go in and query the database for the data that you want. Slide 16, the second part is building on the previous slide. Once we have all of that, then we're able to start developing these domain patterns. And this lists a few of the ones that have emerged as we've gone along. There's a lot more that we need to do, but these are things that have come across because we've had a need for them. So we write an interface to get this cut type of data, and we put it there in the repository for anyone else to use, and hopefully also the extent. As I think I mentioned before, the OVID layer itself is extensible, meaning that you can define a Java concept of a patient, and you can just have a few properties on that patient, that you're most interested in multiple times. And then you can extend that to be, all your patient contacts. So you'll, of course, get ones in the base class, as well as all the other things that you add. And Java supports single inheritance, so you can build as many of these as you want one at a time. I'm not going to read the list, but you can see there's probably some things that most applications could be interested in. The drug information that comes from those drug files, vital signs. These domains may use low-level FileMax to get data. They may use existing RPCs to get data, and many of them use a mix of both to get what's needed for the application. The way that we usually approach things is if there's an existing RPC that does the work that we need, then we're most likely to use that. If there's a piece of data not represented in an RPC, and there's not a good reason to write a new RPC and create the kit still, that would do that and get that in the patch string, then we would very likely go to the FileMax call. As far as ease of development, one thing that turned out to be quite nice about the way we've implemented OVID are the people who write the launch code. And sometimes that, the Java guys, so a lot of times we also have people who just want to write launch code. They don't have to change anything about the way they write it. They will
thank you, Andy. So just to reiterate, if you look at these and picture these as objects with data and services within them, these are the sorts of atomic elements that OVID builds, and then on top of that, we've had developers build applications, web apps and iPhone apps and other things to get access to these elements. And as Andy mentioned, some of these are currently available. Eventually, they'll all be available. It has more to do with timing of releases than anything else to get it out there. The nice thing is these are all extensible as well, so you can add to them. Yes, sir.
What is the coverage?
No, I wouldn't say 50% even. I mean, the Vista itself is obviously huge. We're talking about thousands of files of data, tens of thousands of fields. So coverage-wise, it's not even going to, probably even in double digits coverage. The point.
That's the question that comes up a lot of times with our new developers is that when people ask, is this an implementation of this in Java? And I suppose you could try maybe to go through and expose every RPC and parameters and outputs. But what we're trying to do is build these things as things come up that are useful. You know, our mantra is once we create something, we put it where it can be reused by someone else.
So one of the things that I think the core of your question that I want to bring up is if you look at the history, if you look at the RPC file, anybody that's looked at the RPC file, there's hundreds, thousands of these things sitting there. Some of them overlap, some of them are duplicates. I mean, they were designed by obviously a dispersed group of engineers, and they're not organized. The idea would be to use this sort of technology to kind of organize and bring those together in a more organized fashion. And one of the things that Andy and we have two developers, Andy and Jeff Apple. I should have done a better job of announcing or introducing. Andy Pardue's on the call, one of our senior architects, and Jeff Apple, who couldn't be on the call today, another senior architect, work on this technology. We're trying to do is come up with some means to version control these things, and as services that then you understand when things get deprecated, when things are available, etc. But the idea would be to not just expose everything blindly. That could be done programmatically, but I don't think it's very useful. If you look at the RPCs alone, there's a ton of APIs there within the RPCs, but it's difficult to know when to use a particular one and in what context they're supposed to be used. And this is a bit more of an organized way to do it, we feel. No, actually that's that's a question that Andy and Jeff hear from me all the time. Is, you know, we've got now 4 main projects internal that are using OVID as the back end, and we're constantly asking, you know, is performance an issue? Caching was added for some of that, connection pooling was added to deal with some of that, but we haven't yet really encountered a problem. We worked with the DoD on a recent project. We'll actually be talking about it, and the principal investigator on that asked, you know, at the very beginning, wanted to use OVID as the underlying technology, but was very concerned about the performance. And as we started to get into it, he was just, you know, okay, blown away, fine, this isn't a problem anymore. As he started to see the queries and see how things were moving along, that became less of a concern to him. Okay, so speaking of which, a timed segue there. So we're going to talk a little bit about some work that we did on the distributed decision support and KMR project for the DoD. It's a big project. We have a number of little pieces, and we're going to show you an extension of some of the work that we did. So this is a project that Dr. Fry and Dr. Stephenson talked about at the meeting at the NLM a year ago, I think, at this point. Basically, Medsphere was contracted to assist in 3 elements: data services from RPMS and OpenVista up into the middle tier, we're also assisting with, I'll say, service orienting, basically taking the JBoss Drools rules engine and providing some service architecture around it so that it can be used within the middle tier, and then a web application container for the view-centric framework on the front end to show a web app in the GUI that would support some of the underlying stuff. I couldn't even begin to explain all of the pieces here. The idea is really what we're talking about is this very bottom part here, agency data access and services, is what this little box says. This would be any of the EMRs that are out there. In the case of Dr. Fry's project, he's looking at RTMS because he's doing a study on decision support there, and he's looking at Vista. And one of the key elements to this was he wanted to make sure that the services ended up in open source, so that others could use them. And just as Andy said, that those domains we looked at a moment ago, many of those were built as a part of this project. And so really what's happening is we are, through a service and then through what they call their CAL layer, Common Access Layer, we're providing data up in essentially a CCD format, a C83, what data is available to fill in a C83 from an RPMS or OpenVista database. Goes into the middle tier. They have some decision support and rules that run and may fire notifications up into the client on the top end. And so if you want to read more about the project, I don't want to go into it. There's a link here at the bottom. The presentation will be posted on the World Vista website. You can go to socraticgrid.org and look at the work that they're doing. The only thing I would plug for Dr. Fry is a lot of this middle tier piece, if you will, is actually being built around NHIN Connect. So a lot of this middle tier, the plan is for this to be released via FHA's NHIN Connect project, and a lot of this should be showing up in open source in the future. But at this point, he's ahead of their release cycle, so I don't think any of it's there just yet.
So,
Yes.
when it shows up as part of NHIN Connect, it's available as a FOIA.
The NHIN Connect project is actually FHA releases under, I believe, the BSD license. So it's a pretty free license.
It's available.
It's an open source license. It's available, and the BSD license has almost no basically attribution is the only thing that you have to include a file that says thanks to the FHA or whatever.
Thank you.
Mm-hmm. Okay, so I'm on slide 18 here, Andy. So this is the KMR services slide.
Okay. As Ben mentioned, we're a part of this bigger project that, of course, we're a data provider for them. They want to be able to get data from different clinical data sources, and we're providing one for RTMS initially. And of course, we'll be able to provide for OpenVista, but the CAL layer, they find that this is something that the KMR project came up with for specification, a cloud-based web service that the data providers like us, Medsphere in this case, was code to, and it's all built on top of the NHIN Connect layer, as Ben also mentioned, and it's implemented as a SOAP-based web service that returns these HL7 v3 RIM objects in a specific format. So it's really conducive for a server-to-server type web service interaction, and that's really how it's used. It would not be, you could hook up a Visual Basic client, and connect to the WSDL, and you could get all the API, but it would be very difficult to program against because of the nature. If you've ever used the version 3 of HL7 with objects, you know how difficult it is to create a request, even to say find a patient with this last name. It would be very difficult for Visual Basic kind of programmer who would want just to call one method with the last name, and it doesn't work like that. Anyway, we implement this web service, and then once we've implemented that service, we're free to do what we need to get the data and map it back into this CAL layer. So that's what they call their mappers, or the data, or the programs that do the work for the web service, get the data, put it in these HL7 objects, and then return it. So of course, we use OVID to be able to get the data. We had a few areas that we had when we started this project that we did not have support for, like immunization. We had not had a need at that point to pull immunizations out the way that they were needed for CAL, so that was something new, and we put it in our OVID domain repository. And in the next release, you'll see that that's available. This is an enterprise Java Bean architecture. It runs within a if there's coding available in the data, we'll return it and we'll classify it as such in the HL7 object for this TC doesn't define. At the bottom is the list of the things that currently the Cavaliers has an implementation for more things than this. So this is what we're currently implementing. We can find patients, we can find providers, get the full patient information, which would be the next of kin and guarantors and all of that as it's available. Get a list of problems, results. Well, I won't read the whole thing to you. You can see that it's what a lot of people consider it pretty clinically important domain.
Okay. So we wanted to actually try to consume this and show you the use of these services that were built. So what we did, and Andy, step in when I get this wrong, but we took we have a database that's anonymized, has a decent amount of patients in it. We'll say thousands of patients in it from RPMS. We took the domains that were just referred to and built a XML file per patient. We used OVID to pull those out, and as it states there, a few hours of time. I don't know, Andy, how long it really took you, but the point was that we were able to walk through the database and pull as much data out as we wanted.
Right. In this case, we were able to reuse the code that we used in the KMR project. For instance, we needed the code with the data classifications that PopHealth could support. PopHealth can populate, it appears, a complete CTD, but right now they only report on Q6. So to save some time, we created our CTD disk container thing that we had that PopHealth would be interested in. For instance, as part of the KMR project, we already were repeating a list of problems coded into the HL7 RIM objects that we could convert that to XML and fit that into a CTD XML representation. So we would get it free. So we would just iterate through all the patients in this large database, and we would get the problems. We would look for the ones that we knew PopHealth was interested in, hypertension, diabetes, and there's one or two more. And if that patient had that, then we would put that in the CTD, and the PopHealth has an import facility that works pretty good. We would put the directory CTD files, and it will just go through and import them. And it does the back end does a really good job of importing kind of a new product, an open source product. Yeah,
so we didn't, I didn't provide any background, I apologize. So PopHealth is a project that was released through FHA. It was a project done by MITRE Corporation. Let me just get it open here. So it's basically a little web reporting app that has a population of patients. It's obviously population. Pop is in PopHealth is population. And you're looking at a population of patients, and you're slicing and dicing that data based on various factors that it's read in from the XML file. One of the things that we noted on the last slide was the actual the way that it imports. While it works well, there's certain areas where the coding is not correct, so it doesn't necessarily use the proper clinical coding, and we had to kind of munge data a little bit to get it to work correctly. Andy, I believe, had a brief email conversation with one of the developers, and it's something that they're aware of. To be fair, PopHealth's only been out for a matter of a few months, and it's on like version 0.2 or something. So there's a number of bugs in here which I'll point out, at least the ones we've seen, but it actually, for a first release, does some interesting stuff. So we have a population of 7,500 patients loaded in here. You can see we're looking at the influenza vaccination report here, and basically what that's saying is, okay, show me basically all of my patients, anyone between 0 and 80 plus years of age, who's had the influenza vaccine. So I'll just scroll down so you can see here. Down here you've got the influenza factor, or the immunization factors, so you can see about 53%. So this is a very simple report kind of showing just a few factors. You could actually do some custom reporting to change this around if you wanted to further segment. There is a link here, which I won't click because I know that there is a bug. You can't actually get the list of patients, of course. That's the idea. Would be you want to slice and dice and get to your patient registry and be able to understand clinically who you need to work with on a particular issue. If I click that link, I know that I'll get an error. So if you look at another one here, if we look at the hypertension, I think this one's a bit more complicated.
So, can the user define these reports? Are these reports?
They have canned ones, and there is I'll show you, there's a new report function that allows you to kind of drag in the factors that you want. And it's not smooth just yet, but you can see where they're going with it. And I think it will work. I think it's the type of thing that you'd probably be interested in, Matt. It's a very simple interface to use, and as long as the factors are loaded correctly, basically you don't need any computing skills to run these reports, you'll see. So in the case of hypertensive with blood pressure under control, you could see there they've got their range. Basically, anyone with a diagnosis of hypertension, of which their population has 11%, and between these ages, 18 to 80 plus, who has their blood pressure under control, and these are the factors they determined as under control. Obviously, you can change your references however you want. That's the point of the reporting. And at the top here, you can see, they believe they've got 90% under control, and you could do this report in the reverse, so you could get a patient registry list of folks you need to call and get a hold of and make sure they're taking their meds or getting their exercise or eating right or whatever, however you're going to help them with their particular issue. So Matt asked about, can you customize? So I played with this. You can customize. It even gives you the option to save it, but it doesn't seem to save the reports yet. And by the way, the reports that are canned, you can modify on the fly as well. You can drag these factors around. So for example, if I said I wanted to see all of my, let's say, I don't have any in this range, so that won't be very fun. I'm going to drag my 18 to 30-year-olds, and I want to see the ones that haven't been immunized yet. So you can see that I've got 516 patients within that range that I've got to get a flu shot.
So how is the database carved in the first place? Because there's no time component on it. Normally you say in this quarter, this is many, so when you do the reporting, you're doing it by a certain time element.
So I know a little bit about the Pop Health's original work was part of the Pop CCR project in New York, and they basically wanted a way that local providers could send in their current CCDs and feed them through. Basically, think of it as like a Scantron. They have a coded reporting system they want. They feed in a bunch of CCDs. They get out a list of patients, and they can send them.
So this is really for the CCD uploads. It's not really to report measures or anything like that.
At this point, no. If you look at the Pop Health site, there's some questions there around, meaningful use and other things like that. Probably not doing all of the reporting that you need at this point.
But it's extendable.
Yeah, it looks like their first release. Looks interesting to me. The point here is really taking that data, using OVID to basically build up these list of documents based on the domains. Out of one project, build up your list of XML files, load into this, and do something else interesting with the data. I would say, again, their coding leaves something to be desired at this point. Andy, I can't recall, hypertension wasn't coded as an actual ICD or SNOMED. It was like a text string or something. Is that right?
Right. You can insert the data properly coded. It uses the Postgres database to store data. So you can continue these from several different data sources and pair together. The problem is the reporting tool to identify a hypertension problem searches for the text hypertension rather than the codes for hypertension that you would want to select. And they recognize that as a problem, and what they want to do is add the ability to also define code. I think they're probably going to do a lot of work on the reporting, so their back end is pretty good. They get the data in there, I believe, pretty dependably.
So one other question, which I hope isn't too bothersome, but when I look at, when a physician looks, or people look at something like LDL, it looks like one piece of data, but in fact, that LDL could come in from a lab interface, or a patient could bring that LDL to the physician and say, look, I got this done last week. How does this take all the different ways? I mean,
so think of it this way. I think I know where you're going with the question. This tool is really, you take your source of truth and you feed it into this tool. So you've got to have your data set up in the right way before you feed it into the tool.
right.
So if you're taking LDLs in hand from patients and you trust those, make that accession that into your
So
source
you
of truth.
can do that.
Yeah.
That's an important part, because that's really maybe 30%, or maybe they're sent to other labs than the ones you have interfaces to, or something like that.
And you've got to get them.
There's a lot of reasons why you have to have more than one way to get it in, and what I see as a limitation in a lot of electronic components, they don't have it. They only have.
If it came from their own
the lab interface, then
Yep.
it's included.
Yep. This doesn't solve any. Pop Health doesn't solve any of that. Pop Health is the back end of that.
So that's all just how it's coded.
If you're using, RPMS, EHR, if you're using World Vista, if you're using GE, whatever, however they get the data in.
On top
Yeah.
of it and so
Exactly. So the point was, we just wanted to kind of show the use of this particular some of the OVID stuff as an integration piece, as an extension of an existing EMR, so you can see what we're doing there. I'm going to switch gears now and go into FileMan Projection. I've got a few more demos to do on FileMan Projection, but as I mentioned yesterday, oh yes, Chris.
On your previous slide, CCD creation, is that something that's all using OVID and not using the CCR CCD project? Is that totally different?
Correct. So this is using the CCD work that was done as a part of the KMR project. We basically extended upon that. And really that has more to do with that contract was what we were working on more than anything to do with that the CCD CCR project, which we worked on as well.
But I would point out that you could also use OVID to access the RPCs from the CCO CCD project if you wanted to use that to create your CCD. We just didn't do it in this case because we already had we needed to iterate through the domain, and we wanted to do that in code. We really didn't start this Pop Health thing until last Wednesday as far as trying to get the demonstration together, so we moved, but it was as quickly as possible.
Okay. Any other questions on OVID before we move on? Okay. So FileMan Projection, as I mentioned, is a SQL-like projection technology. If you're familiar with the Cache FM to Cache product, it's the same thing as that, but it's agnostic to the M engine that you're using, and it's open source. But it's certainly not as mature. It was only released in January, and it currently is just in our open source projects list. It's not one that we support commercially either at this time. It basically uses a connection back into the M database. It uses the Vista SQLi package that comes out of the FOIA system, out of the FOIA release, to help us build up the list of files and tables, if you will, and project those through MySQL. We're going to get into the architecture a little bit, but you can see there's some stats on it. We don't actually have a download release at this point. It's all just in an open code repository, so I can't tell you how many people have actually looked at it. But it has several components which we'll talk about. There's obviously an M component. There is a small Java component, and then there's some C on the MySQL side, which we'll get into. So as I mentioned,
I know Joe Fontes downloaded it and got it working on World Vista.
Oh, great.
Said it worked quite
and
well.
I do know Richard Brahman of EHR Doctors did as well. So there have been some, and from a compatibility standpoint, I wouldn't imagine it would be too difficult to get running on any flavor of Vista. We have been working on getting it working on RPMS, but because of the broker differences, there is some work to be done there. So again, it's M-engine agnostic, runs against GTM or cache. It implements a MySQL storage engine, which is basically a plug-in to the MySQL database. If anybody familiar with MySQL knows they've got a number of different backends that you can select when you're setting up your database, and we just created a FileMan-aware version of one of those storage engines, and then again uses the SQLi package to understand the structure of the files and turn that into metadata that MySQL can use to understand it as a relational database, which is what MySQL understands. What that gives us is the ability to access the data via JDBC and ODBC connections. Basically, any client that can connect to MySQL would be available. The other nice thing is it uses the query engine that's built into MySQL for all of the query building, optimization, etc. So we didn't write any SQL parsing or anything like that. That's all. We leveraged the open source project MySQL for that. There is I'll show you a Java-based schema and data viewer as well. That is a tool that we use to project what we want to project at a file-by-file level. And the point here is that we can simply take the connection, JDBC or ODBC connection, hook up a reporting tool, and start building reports against it. I would reiterate it's read-only at this point, so it doesn't do any writing back to the database. So we're on 22.
The reason that we chose MySQL as the engine for this is because they were the ones who had a documented API for how to plug into it, to plug in your own storage mechanism. You follow that pattern. MySQL doesn't really know that it's calling out to OpenVista to get a file mechanism to get its data. To MySQL, you're just another tool. My iPhone and the others that work as well. So that's what makes it nice. So that way, any query that MySQL can support, we can support it, because all we have to do is provide the data to MySQL and ask for it.
So Andy, good segue. I'm on 22, so I'm showing the diagram.
Okay. I thought we were already there.
So the point is, as I mentioned, there's these other my ISAM and InnoDB storage engines. We just implemented a FileMan storage engine, and then built some RPCs on the Vista side that leverage the SQLi package. And then I mentioned there's this visualizer tool that kind of sits to the side, and we use that. It basically hooks up to the Vista derivative on one side and the MySQL instance on the other, and can say, okay, I want to project this file over as a table here, and allows you to look at the data and inspect it as well. Okay, so we're on 23, Andy.
Yeah, most of these models have to do with performance optimization. This is to make it work as fast as possible. So this is our current laundry list, and we like to do we have the last item there, writability. Of course, that needs to be able to support SQL insert, update, and delete. Right now, if you issue one of those through MySQL, it'll pass that to the FileMan and just say, want to insert this data, we'll just return it, so we can't do that. That'll be returned back to the user. So with the capability that we currently have, one thing that we think is useful that we can support, and that's why we went ahead and released it when we did, is you can attach your report builders to this, and people who generate reports and crystal reports or Jackson or whatever they're used to. They can attach it to MySQL with projected FileMan interface, and they can begin to create some custom reports using those kinds of interfaces that they want to.
Okay, so we did want to continue to test our luck here and do some more live demos. First one didn't fail horribly, so we figure we can do that now. I was going to show you the visualizer first, so let me get there. So this is the visualization tool. So for example, and this is a very, very rough tool, but the point is you can go and You can select file 200, the new person file. You can see the description of it. All of this is basically being pulled through the FileMan interface. You can inspect the columns, look at the pointers, look at the data types, all of those things that would be available via if you were to use the FileMan tools to inspect schema and DD. That's available here. You can look at indexes, data. And so this is basically pulling the first 50 rows. It works just like any sort of query tool that you've ever, the pattern's very similar, but you can go look at how much data is in the database and look at things, again, read-only. You can look at the globals, you can see references, and then we added this spiffy little graphing tool in here. Let's see if this thing works. This is kind of a toy. And so it's basically looking at the pointers that it understands from the structure and showing you what everything points at to give you an idea of the structure. When you get into something, so if I showed you, it looks neat, but from a usefulness standpoint, it kind of, if we look at file 2, and it may just choke on this. From a useful, by the time you get into something like this, it's not quite as useful anymore, because it's very difficult to actually discern what's pointing at what, but you get the idea. I think with some, if somebody was actually interested in this, with some modification, you could probably start parsing this into more usable chunks to visualize the data. That's really the point of this tool, to visualize the data, give you an opportunity to look at the data. Our product managers use this tool rather than having to get into the FileMan arena. Bhaskar, you've got a smirk on your face.
One crazy idea. It just occurred to me, one of the things you might do with this is rather than actually feeding the computer sensitive, is actually convert the FileMan data into something like a mind map file. And then you can run something like read-mind on it, and that has all of the things for zooming in and out and then navigating and so on.
That's an interesting point. I can't recall, Andy. I think this was a Jeff project, right?
Yes, what was the question?
The FM Visualizer was a Jeff project, right?
Yes.
Yeah. Okay. I'll mention it to him. I can't remember if he's a mind mapper, but that's kind of interesting. It's a good point because they basically have all of the tools for visualizing and drilling in on the data.
For us that don't know FileMan that well, but we want to write reports, a lot of times it's really hard to know where the pointers are, so you can get to the fields you want. That would be very nice.
Be a good development tool just to learn about it.
Yeah.
So I don't know what just happened. My computer didn't go to sleep, but the projector.
It sometimes recovers itself.
Okay. Whew. I wasn't expecting. I was expecting the technology on my own laptop to fail, not the projector. Those are usually pretty safe. So, so let me go back here very quickly. Yeah, so we looked at the files, looked at the various data about the files. So let's look at it from the SQL side of things. So let's look at it through a free tool called DBVisualizer. It's basically a Java tool. And what I've done here is I've created a JDBC connection back to the MySQL database, which has the data projected from FileMan. I can look at my tables here. I can look at the new person file. I can, again, look at the schema in a more SQL-like way. Similarly, I can look at the data. I can't recall how much data is in here. Not that much. So I can look at the data. Very similar. Basically, this is running SQL queries in the background. So let's go ahead and do that just straight off. So let's see here. So if we were going to look at the titles of the various, very simple SQL query, basically show me all the titles that are available in the system. And if I run this query, I'm going to get back my list of all the titles with their IENs and whatnot associated. Very straightforward query. Nothing too exciting there. So let's look at, let's do a join. So users with titles. I wanted to spare everyone having to watch me type these out. So you can see here we're selecting from out of the new person table with the title, and then we're matching and joining into the title file to match up each person's title with their name. So there you can see your list of clinical coordinators and health techs, etc., docs, etc. And this is just so you're aware that I realize these queries are really simple, but you saw performance-wise it really isn't that bad. And keep in mind, this is running on my laptop out of a VM. I have 2 VMs running on this, plus all this other software, so I'm amazed this thing's still actually not overheating.
Over 7,000 person database.
This database is not. This is the smaller database. This one is much smaller. The other VM has the 7,500 pop health patients. So
you could put like make crystal reports from this just by.
Bear with me, and I'll show you a open source reporting tool that you can use. So let's do something a little bit more interesting from an SQL perspective. So if we look at the average age, so what's interesting about this, or interesting is relative of course, but we're using the SQL functions average, standard deviation on the age field. But for those of you that know Vista, you know that age is actually a computed field. So it's going to go through and first figure out the actual age, and that's what SQL is providing back to, that's what FileMan is providing back to the SQL engine. The SQL engine is doing the SQL function of averaging. So you can see there, you've got your average age of 44.3 and your standard deviation on the age. So that's kind of interesting. And then we can go with a more complicated query, which I think is this one here. So you've got a subselect with multiple joins, and you're basically going to be pulling back in recent signed notes, I believe, if I'm reading that right. So there's a couple recent signed notes. They were crisis notes. There's the users that did them. So from Matt's question, I'll get into reporting a little bit and show you that, but very quickly I wanted to show you the projection aspect of it, because people think that when I say projection, I'm talking about replication. We're not replicating data into MySQL. We're projecting the data, and all the data is actually living in the real database, which in this case is OpenVista. So I'm going to go back into FMVis, and I'm going to go and project a table, a file. Use the correct terminology. So let's take the state one. Relatively simple. I'm going to go into the Info tab here, then project to SQL, and then set it to project. I'm going to go back over to DBVisualizer and just do a quick refresh. The objects, and there's your state table, all projected with data. So this didn't replicate over. This data is still living in the OpenVista database. This is merely making calls across. It thinks it's accessing a data store. MySQL thinks it's accessing a native data store, and it's actually accessing OpenVista. So to Matt's question, Crystal reports could be used. There is an open source reporting suite from Jasper, and they have a report writer called iReport, which I just used to do similar SQL-like queries and build very simple reports. These reports are not going to be interesting to you from a clinical perspective, but hopefully they give you a flavor for what you do, because I'm just not going to be smart enough to understand what would be even useful. So I'm just going to fire up here. I think I should already have it running. I can just figure out what the right icon is. There we go. So users by title. So in this case, I just take a very simple form. Basically this is a report writer that lets you build a little template, populate your labels and what fields you want where, and you could actually do graphing and other things. And I just did the simplest thing and basically put in a little list of the patients and their, of the personnel titles and how many there are of each of them. So this is an example of a query. I'm not sure if I can actually show you the query very easily. Yeah, there you go. So there's the query. Again, left join, just pull in all those things, and write a quick report. So we can do also sign notes. So it said last 2 weeks, but I actually extended it out because I wanted to get some more data in here, and this database had been sitting kind of static. So you go back over to the designer, so you can see, again, you're basically, as you structure these things, and this is part of the report writer, obviously, is you just lay in the fields you want. You can do some formatting on the text. You can add labels, align them, do whatever you want, and then when you run the report, you get back your output, and you can go back and mess with the data if you want, mess with the format if you want. Marcy.
I'm going to try and frame this question correctly on an interruption. So right now, I'm looking at that crisis note up in the middle. I want to see the crisis note. Can I go down from there, or do I need to go back to CIS and put it there?
Yeah, so in this case, what I'm really just showing you is access to the data through the reporting tool. If you wanted to write a query that, say, built a report that said, built a cover sheet that had your list of notes, and then every underlying page had the actual note, you could do that through SQL queries. In this case, all I'm doing is showing you the list. I didn't pull back the content of the note, but that data is available.
So what if I want to report it? You wrote that query for me, not getting it.
You don't want to see that. That won't be pretty.
I won't do that. Okay. That's somebody on the phone. Okay, so let's say we did that, and I view the crisis number. I'm going to sign it, write it, and I'm not going to put it back in the database. So I want to pull up that crisis number I want to see. And there's something in it that needs to be patient care-wise on the different. Will I have a record number? I'm framing this correctly. You know what I mean? That will allow me to get into that record number and come right back through CIS, let's say, pull off. Immediately, so I'm going to be a clinician now.
Right.
Look at that crisis and say, oh boy, can I direct connect into CIS, or do I have to?
So I think the core of your question is, can you use this sort of technology to build a tool that would allow you to drill through, look at a list of notes, click through, find a note that you're interested in, see something that you want to act upon, and get in and make an order or something like that.
Easy, without log back in, and
right.
record number and all.
So if you came to me and said, I've got this requirement, I want to do this sort of system, I would say, okay, great. What we probably want to do is build a quick web app that probably uses some of the OVID technology, although you could use FM Projection for that, to actually go in and be able to drill through the notes and the workflow that you're describing. This particular tool I probably wouldn't recommend. This is more for static reporting. If you wanted something that provided you with printable reports or reports that you could have as PDFs that you send around yeah, exactly. So this is more static reporting.
Yeah, and I see I'd be wanting to mix and match that technology with this and CIS.
Well, so the interesting thing is, so I'm showing you iReport, which is the report writer tool. It's a part of the Jasper suite. The Jasper suite contains a server-side reporting engine that has a repository of stock reports that you can plug in the necessary elements of the queries that you'd want when you generate the report. So I'm going to try to do that. I don't have any visualization of this, but basically what you would do is you'd write up all these different reports that you want, and you'd have your web-based tool that allows you to browse through your list of notes and click on things and whatnot. And when you got to a web page that you said, well, wait a second, I actually want this as a nice takeaway report that I can send to my manager or whatever, you could actually have it then query back to the Jasper reporting engine for a stock report that has all the nice formatting that you want and pull that down as a PDF. And that's one of the things that the Jasper engine provides.
And that web front end used OVID.
I don't have the web front end you're asking for, but I would build that in OVID. You saw a web front end that we built in a matter of, just as Andy said, we prepared the pop health thing in a matter of 10 days. We did the same thing with that.
Just to clarify a little bit, I think we brainstormed a little bit about maybe leveraging some of what we've done. Of course, everybody wants to do that, but I think what you're trying to do is leverage what's already in CIS, maybe cache credentials or something, and open CIS to that page.
Right.
That kind of thing.
It's a bit difficult. The single sign-on gets a little bit complicated, and we've encountered that a bit when we had a customer that wanted not the workflow that you're describing, but the idea of I'm viewing something as a web page, in a web page, and I want to be able to click through and directly into CIS or CPRS or CareView, what have you. It's that single sign-on stuff is actually difficult to do. It's because of the way web applications and web browsers are designed from a security and a sandbox perspective. It's difficult to break out of that jail and go do stuff on the actual computer, execute things on the computer. So that'd be something that I would say you'd want to talk with whoever you're working with on a project to design something that works for your workflow. You two, you're the one. You guys are brainstorming together. Okay.
Chad, what I'm talking about is allow you to
Well, absolutely, but I think Ben's right. These are the sort of things that you use to create reports that management types look at and pontificate over, that sort of thing. But what you're talking about is like a little application that you basically get the same data, and then you want to go directly to it and view, jump around. And that would just be a different tool, but it's quite.
Suppose you had surveyors in house, and they were looking at a list and wanting to do more of some of those crisis notes. I was just wondering from your perspective, as you were putting the doctor's note, if that would have been.
Oh, it'd be great. It'd be great for sure. One of the things you can do when auditors have a specific list is you can give them access to the reports tab into a list. And so when they go in, all they see is the list they're supposed to see. And you can also make it so that they're inactive after a certain amount of days. So, you can already do that in sort of this way, yeah.
Depends on how much you want to customize your workflow.
Yeah.
There is some of this stuff there.
It's unlimited flexibility.
So
It takes money and time.
let me just show you very quick money and time. That's exactly right. So very quickly, I'll show you one last one here. So we've got patients and allergies. So this is basically your list of patients, their allergies, and or one of their allergies, and who the provider was that observed that allergy. Very simple query again. If I go back to here, relatively simple SQL query in the SQL world. The thing that I again wanted to show was from a real-time perspective. If we go into a particular patient, and so now I'm in good old trusty CPRS here, and I'm looking at a patient, and I want to say write a new note on them, and let's go ahead and write a crisis note, since that's what Marcy wanted to talk about. And I'm going to sign this note. So now I've got a new note in the system, and I want to go back in and make sure my reporting is up to date. So I'm going to go back over to iReport, and I'm going to run this. Oh, I'm sorry, I'm in the wrong one. Notes from the last 2 weeks. I'm going to refresh this guy. And we should have our new crisis note there from this morning. The times are off, but you'll see there at the top. Maybe this was a bug. Let's see. Maybe the date's off too. Let's write another one, make sure I got it right. It wouldn't be a demo if something didn't work right or wrong. Okay, signed. Yeah, there's our new advanced directive. Just the dates are wrong in the VM. So the point being, again, that these queries are happening real time against the real database. They aren't replicating over, and that doesn't take any time to get your new data and get your new reports up to date. So did everything. It's replication. We ran the report. The last thing I would say, quick plug, Connor left the room. He was at the back. You know what, I'm sorry, you had a question in the middle there.
I was just suggesting what you were talking about earlier. You could probably use business object later to use Ready to do you've got the MySQL interface.
The kind of workflow, yeah. The thing to recall is just this reporting tool is read-only at this point. So if you want to do any writes to the database, we'd recommend the OVID route. So thank you. I'm sorry I went over. Last plug here for Connor, who left the room. He's doing a semantic web EMR later this afternoon. I definitely suggest you take a look at that from a technology perspective. It's very interesting stuff. And then I'll be talking tomorrow just as a Medsphere representative tomorrow morning. I'm sorry, Friday morning, if you were interested in that. Any other questions? Thanks for your time, everyone. Thank you, Andy.